Hello everyone, this is my singing arc experiment number 3. Much more power. It's way clearer now. This time I'm using the A-stable multivibrator, using 2 transistors there. And I'm actually inputting audio through this capacitor. There's the MOSFET. There's the flyback. Here is the circuit. I'm feeding the audio signal in through a 0.01 microfarad cap into a base of a transistor. Here's a potentiometer, basically as a voltage divider for the base resistors. The flyback. And there's a 0.001 gate protection capacitor, and that's the flyback. Online I found a formula for these ones. F equals 1 over 1.38 brackets R times C brackets. F is in hertz, R is in ohms, C is in farads. So I filled out in the formula 68 kilo ohms is 68,000 ohms. And then I went from 100 picofarads to 0. whatever farads, and I put it in the formula. And I got 106,000 hertz, which is 106 kilohertz. Basically, that's what it operates at. It's much clearer now. There's not much that high-pitched frequency in the other circuits. The other circuits I used 10 kilohertz, but this time it's now pure. There's the arc. Much bigger. It's only 1 amp. That is beautiful. And the fan is not starting. And now I'll put in music. Here's the input wires. Just plug them in. It's really hard. Okay, I've plugged them in. And this time I am gonna turn it on. For me, that is really clear. That is extremely clear frequency. Just set it up a little bit. Fix it up, but it's really annoying. And I'll play the audio now. Nice. My best attempt. It's much better now that frequency, I got rid of the high pitch frequency. Well, here's the circuit final detail. There's the two transistors, BC108. I chose these because they can go up to 500 megahertz, plus they have shielding around them which doesn't interfere with anything. There's the resistors and the tiny capacitors, 100 picofarads. There's the audio input capacitor and the audio input. There's the 5 kilo ohm potentiometer. This resistor is not in the circuit. I use this to slow down the fan, so it's really quiet. It's optional. It's 120 ohms, but it's rated for 1 kilovolt. There's the base. There's the gate protection capacitor and the flyback diode. And underneath here, there's the 1 kilo ohm resistor. I recommend about 2 watts to dissipate the flyback pulses to protect the MOSFET. It's so much better now. And here's the final circuit for anybody who wants to rebuild it. It's really simple. And there's your formula. Plus, here's the driver circuit for my Tesla coil from my previous video. I did the formula as well. It's about, the capacitor is 0.1 or 104, and the base resistors are 4.7 kilo ohms. So I did the frequency thingy, and it turned out to be 1.5 kilohertz. This formula only I'm talking about, it only applies for 5 volt power supply. I'm using 9 volts instead, so my frequency is way higher than 106 kilohertz. It only applies for 5 volts input instead of 9, and that's how it works. And then you fill in the frequency, F in hertz, R in ohms, and C in farads, resistance and capacitance frequency. And that's it. Thank you for watching this video.